Welcome again. Today on Chem in 3, we look at the difference between heat and temperature. We recall that neutralization is exothermic. And finally, and most significantly, we look at the difference between paper chemistry or theoretical chemistry and real chemistry or practical chemistry. Heat, according to caltech.edu, is the total energy of molecular motion in a substance, while temperature is a measure of the average energy of molecular motion in a substance. Temperature does not depend on the size or type of an object. In other words, if you have a small cup of water at 50 degrees Celsius, you can also have a large tub of water at the same temperature, 50 degrees Celsius. But the tub of water would have a lot more heat because it simply has more water molecules. Another way to look at this is to think about your skin being touched by a speck of really hot oil with a temperature of 500 degrees Celsius. That tiny speck would cause just a minuscule burn on the surface of your skin. But if you were to pour 5 liters of water at 85 degrees Celsius over your hand, you would suffer from a very serious burn because you would be exposed to a lot more heat. So now let's take a look at this neutralization reaction. Here we have 10 milliliters of 1.5 molar hydrochloric acid reacting with 10 milliliters of 2 moles per dm cube sodium hydroxide. A theoretical question says to us that when this neutralization happens, the temperature rises by 10 degrees Celsius. So the student is then asked to predict what temperature rise you would get when you double the volumes. 10 degrees Celsius or 20 degrees Celsius? And if you grasp the difference between heat and temperature, then you would be able to realize that the answer is not 20, but 10 degrees Celsius. Because even though you have double the volume, it doesn't mean that you're going to have double the temperature. Doubling the volume means that you double the amount of heat released in neutralization. But you must bear in mind that that heat must then be dissipated over twice the number of molecules, which would mean that the average kinetic energy or the temperature change should remain the same. But this same temperature that you expect is only going to happen if you have ideal conditions. In other words, you must assume both beakers are exactly the same size, and most significantly, you have to assume that there's no heat loss to the environment, because if there is heat loss to the environment, if this reaction is not happening in a perfect calorimeter or something that's not going to lose heat to the environment, then you would expect that the larger volume of liquid would retain a greater percentage of its heat than the smaller volume of liquid, and then you would not expect the temperature change to be exactly the same. But it certainly would not be twice. And this is, of course, the difference between studying chemistry out of a textbook purely at a theoretical level and then experiencing practical chemistry. Let's move in now and take a closer look at the actual experiment.
Yeah.
What does it say there? 24.1?
24.1, yeah.
24.1. Sodium hydroxide. It's saying 24.2 now that I've put in my sodium hydroxide. Then I'm going to neutralize with HCl. My hand on the beaker is a factor. I'll have to keep my hand on the next one just like this to make sure that it's controlled. 30.7 is where it's
22.1 degrees Celsius.
22.1, yeah.
22.1. So let me bring it down here now. I'll see it says 21.9 now. Then I'm going to try to keep my hand like in roughly the same position to control that. The air conditioning is over there. It's on. We're assuming that it hasn't changed the temperature in this room. The fan is running as it was. All of those control variables. Temperature there is 22 right now. I'm going to put sodium hydroxide inside. It says Temperature has gone up already with that. So that's 23.7. Now I'm going to add this. Neutralization. It's already gone to 26.8, 32.4.